So we're going to finish 4.1 doing the last 4 problems. The last 2 are what I would call pure word problems, but really 23 and 24 are word problems because it is actually phrased in that format. So let's look at 23. Find the x values where the slope of the tangent line is 0. That is the same thing as saying where the tangent line is horizontal. So it's actually asking you to do the same thing as number 22. Okay. Find the derivative, evaluate where is it equal to 0. So 3x squared minus 8x minus 7. If I look at this problem and I try to factor it, it's not factorable. So this is a good reminder. If it's not factorable and you have to set it equal to 0, first glance, is it factorable? If not, we're going to use the quadratic formula. So remember, it's minus b, so the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. So it's a refresher. You are expected to know that. So opposite of b is 8, plus or minus 64 minus 4 times 3 times negative 7. Very careful of your signs. All over 2 times 3. This gives me positive 8 plus or minus 64 plus 84. So I add underneath, which is my discriminant, which gives me a 148. You are expected to simplify this. 148 is 4 times 37, and 4 is a perfect square. So I can pull out a 2 by taking the square root. Two ways to finish this off to simplify. You can pull a 2 out of the top and cancel it, or some of you it's better, you're easier to see it if you break it up using the rule that we're dividing by a monomial. So this gives me 4/3 plus or minus the square root of 37 over 3. The mistake a lot of people make is they try to cancel right here with the 8 and 6, but this 6 divides into both the radical and the 8. So my answer, it didn't ask for what, like a small one or a big one. It says, what are the x values? So it's 4 plus or minus the square root of 37 all over 3. (24) says find the point, which means the x and the y, where the slope of the tangent line is -2. Find the derivative. So 12x plus 4. Plug in the -2, which is what we want to find when it is equal to that. So I'm going to subtract 4, which gives me a -6. Be careful. I'm dividing by 12. So that gives me a -1/2 for my x value. That's part of the answer. But I need the y value because I need the full point. So now I've got to plug that back into the original function because that's the original point. So f of -1/2. Be careful with your parentheses. This would be 6 over 4. This would be a -2. So I have 3/2 minus 11. I can always rewrite the minus 11 as a -22 over 2 to get a common denominator. And that gives me a -19 over 2. So my answer here is a -1/2, -19/2. The whole point is the x and the y. Back to the words marginal. Remember, that's not any different from before. It's saying find the derivative. Here is again just putting it in words. Approximate cost of producing one more item. Approximate revenue for selling one more item. Profit gained or lost. So if it's a negative, it's lost. Okay. So this again explains a little bit why this is where we would actually use it. Management wants to be careful to keep track of those marginal costs. They don't want the cost to be increasing. They don't want revenue to be decreasing. So again, here, if the marginal cost of producing an extra unit exceeds the marginal revenue, you're losing money. So reading number 25, assume that the demand function is given by Q is equal to 5,000 minus 100p. Find the marginal revenue. So this is a review back from test 1. Remember, marginal revenue would be taking the derivative of the revenue function, but we need the revenue function. It's not given to us right now. Revenue function is defined to be price times quantity. So my revenue function is equal to we're no longer putting the revenue in terms of X for this problem. It actually gives you a hint in the parentheses. Use R of Q. So Q would be my quantity, P would be my price. So remember when we did this before, we would have taken P times the quantity. So what we need to do is take this demand function that's given to us, and right now it's solved for Q, but that's what I want in my answer. So I need to take that piece and solve it for P. So I'm going to add 100p to both sides. And then I'm going to subtract Q. And then my last step here will be to divide both sides by 100. If I divide 5,000 by 100, I'm going to get 50. But be careful, you have to divide every single term by 100. So what I did there was divided every term by 100. So this is my price in terms of Q. How did I know I wanted it in terms of Q? If you look back at the sentence, it says find the marginal revenue for the following production levels, values of Q. So it's telling you, instead of X being our quantity, we're using Q, and that's relating to this formula from above. That's how we knew we needed it. So we actually are using R of Q, where I have price times Q for quantity. Here's my price. So R of Q equals 50 minus 1 over 100 Q times Q. I don't know how to take a derivative when I have multiplication. So right now, I do need to multiply that out. This is a parabola that is facing down. So here is my revenue function. So I want you to stop and make sure you understand how I got that. Revenue means price times quantity. In the past, they would tell us that the price was $25. They didn't tell us that now. They gave us the demand function, which related the price and the quantity. Because this problem says it wants the value of Q, we had to rewrite price in terms of Q, which is what we did here. We then plugged it in for price. Which is what I did right here, and then I multiplied and simplified. At this point, you are literally taking the derivative of that, which is not hard because it's actually a polynomial, and then you're evaluating at the values. You actually do have this on Canvas. It'll say 4.1, 4.2 word problems. So you have me all worked out where it's a little bit nicer and neater, and it also shows you how to write the wording out for the answers. So I, again, explained it and walked us through it, but this is where we got this function, and there should be a Q squared there. No, sorry. Here's my revenue function that we found on the other page. Here's my derivative of my revenue function. Once I did that, I'm just evaluating at it, and it says at a production level of blank, the next unit will produce approximately blank in revenue. Because remember, it's always the next unit that we're talking about for that piece. And again, this whole page right here is nicely printed out in the Canvas shell. So I'm going to look back at number 26. So 26 says, often sales of a new product grow rapidly at first and then level off with time. This is the case with the sales represented by the function. So here's my sales function, where T represents time in years. Find the rate of change of sales for the following number of years. Rate of change means find the derivative. It didn't say it in that form, but that's what it's saying in terms of years, which already is what the formula is. So take this piece, take the derivative, and then evaluate at those values. So wrote it out here. Here's my derivative. I actually rewrote it with a positive exponent. And I do see a mistake on that one. There should be a square there on that piece from copying it down from the other piece there. When you look at the blue portion I plugged in, S prime of 1, 1 squared is 1, which is in the denominator. Over here, 10 squared is 100. So I had that piece correct. So the second year will produce approximately 100 units in sales, because that's coming from here, because that's the next year, right? The 11th year, which is the next year of S prime of 10, will produce approximately an additional 1 unit in sales. Okay? Because what we were doing was finding the rate of change of sales when we use this formula. Last piece I just want to real quickly look at is in your Canvas shell. If you click on Module 3, again, these are the handouts for class. This is the ones I actually use for 4.1. Here are my personal extra examples that I've done. Now, some of them are from the textbook, but what I mean by that is I've actually created these pieces and put them on here. There's a summary of all the rules for Chapter 4. There's more examples of every section for textbook. Product and chain rules, quotient rules, those are ones people tend to mess up on, so I have some extra examples there. Have your review pieces, and on the bottom you'll see here are my three for 4.1. Here are the ones from Stevens for lectures, and on the bottom there are extra examples worked out on videos, and y'all will find that sometimes you need some extra examples, and I've tried to label these pretty nicely so you can see what you have. Okay, so really good one to look at in this chapter if you find yourself needing extra examples.